Energy is vital to our daily lives. And as the world's thirst for energy continues to grow, the challenge is to meet this growing demand in responsible and innovative ways. This is the story of how Shell is helping to meet this challenge. The Shelburne Basin, Nova Scotia. It's here that Shell are searching for oil and gas, and to help them in their quest, they are deploying, for the first time in Canada, the very latest in exploration technology, 3D Wide Azimuth.
One way that I try to explain Wide Azimuth to people is, suppose you were going to look at the Washington Monument. If you wanted to really understand the shape of the monument, you'd want to be able to walk around it. You'd want to be able to look at it from different directions. In conventional 3D seismic, you look at it from one direction, whereas in the Wide Azimuth, you look at it from different directions. So you're able to kind of march around and look at it from different angles, and that's what allows you to ultimately construct a better image that leads to a better geologic interpretation, and hopefully, in this case, we hope to traps and accumulations of hydrocarbons.
We have pre-existing 2D data from surveys that have been done in the area, but they don't really provide us with enough confidence to select the best drilling location. So, we go back out, we'll now do the Wide Azimuth, which is a new technology, and we hope it'll give us the best possible chance of finding the appropriate drilling locations and making a discovery.
The optimal drilling location could be anywhere within the series of blocks for which Shell has a license to explore. They cover 19,895 square kilometers.
In this particular experiment, we're going to have 12 streamers, and they'll be 8 kilometers in length. So it'll be about 96 kilometers of streamer that's being pulled by this vessel. The streamers are deployed off the boat. They have a receiver every 3.125 meters, so that's a huge number of hydrophones on the thing. You also tow a seismic source, and that source puts energy into the water column. It reflects off the geology at depth, and then it's returned and recorded on those streamers, and then starts a very long process of QCing that recording to make sure that everything is going well, and that's what's done in this part of the boat. And ultimately, then it's processed to an image that geologists and geophysicists can interpret, and in this case, look for oil and gas. We're trying to image very steep walled salt that's overhung. It's very complex subsurface, and you need the ability to collect data from a lot of different azimuths in order to build that image.
The data quality from the Wide Azimuth 3D is a huge step improvement. So we're obviously hoping that we see that same step change in imaging, which will enable us to pick that sweet spot for the drill location.
The data is then analyzed by Shell geophysicists in Houston, Texas.
The first thing we do is we map all the major sequences. So this is the structure map of the water bottom, right? And the bigger map in the background is made from the 2D data. And these three, you can probably judge from the shape, is mapped from the 3D. Just from the look of it, you already see on the 3D map, you see a lot more detail. On 2D data, it will take a full week actually to map it around. But for 3D data, we're able to do it in a half day. It's really critical to have this kind of product at early on of the venture, right? So we were able to speed up the drilling campaign, speed up the entire timeline.
It's a highly complex operation on a vast scale.
The vessels for this project have been mobilized from various parts of the world, so bringing a fleet of 4 seismic vessels into Canada and getting them here all on the same day is quite a challenge.
Oh, it's very impressive. I haven't seen anything like it. I mean, it's my first time on a seismic ship. The amount of work and the amount of technology on these boats is just amazing.
This is maybe the 3rd time I've been on one in my career, and I'm always astounded at how things have improved over the time before I was last on a ship. So the technology is evolving so rapidly. It's just really incredible, actually.
Shell also wanted to make sure that this new seismic technology was used in an environmentally responsible way.
The very nature of seismic work is that it puts sound into the marine environment, and there have been various studies, none of them particularly conclusive, about whether that's harmful to marine species or not. Certainly the company are aware of the need to be careful with marine mammals, but there are other fish and species in the ocean that may or may not be affected by seismic noise. So it's uncertain whether or not seismic activity is harmful to some of these species. It's got to be done. You won't find the oil and gas resources without it. So we understand that from the fishing industry perspective.
Obviously, it's a new area. There's a lot of environmental concerns. So, over the past year, we've had to produce an environmental assessment to demonstrate both to Shell and to the regulator, of course, that everything we are proposing conforms with Canadian environmental requirements and, of course, Shell's own environmental requirements.
One of the things I'm especially proud of is we went and did acoustic modeling to better understand the seismic source, how it propagates in the water column, how it propagates differently in the summer than it does, say, in the spring or the fall. And we've tried to include all of those things in our environmental assessments so that we have the least amount of impact on marine life that we can.
This ship got a green passport and is called as a clean class vessel. Nothing goes overboard from this vessel. That's a first of all company policy, nothing to be thrown overboard. On conventional vessels, let's say when you do the cooling of the engines, the water goes overboard. Here, warm water goes through the coolers and the water from the outside is cooling the calorifers. So just nothing is going to the ocean. The emission from the funnel is almost completely clean. And on top of it, every project we go in, we have a mammal observers and passive monitor as well. So we can see what's on the surface and we can see what's underwater as well.
First and foremost, but we're not going to do anything if we don't believe it's safe. So safety is more than a priority, it's a core value for us. If we can't ensure that our plans are focused on no harm to people, the environment, the assets, we just don't want to do it.
But what they did want to do was create opportunities for local communities.
Economic development and resource development go hand in hand, and the Aboriginal people welcome economic development as part of their growth within society. And having lived a marginalized life for many years for many different reasons, the development of oil and gas exploration is a very important factor to them. And when you see corporations coming in like Shell, taking the time to engage the community, that's welcoming because it shows that there's an open hand, an extended hand.
The guiding principle here is that we want to have full and fair opportunity for Nova Scotians. So the way that we provide local benefits comes in a lot of different ways. It comes in projects like this where you're having supplies and come to the vessel, the food, the fuel, those kinds of things. It also comes in terms of employing people. So having people on these vessels that are principally Nova Scotian, we hope, but also Canadian in a larger sense. So we try to work with all the communities as well to try to make this a positive experience for everybody.
I see it as an opportunity for some of our younger Mi'kmaq people that are well educated, and I see it also an opportunity for the children that are in the schools now in trying to train them to work in this field. It'd be interesting to have Shell at career fairs where the communities gather all their students and they come in and look at opportunities and careers that they might be interested in.
This move by Shell, by being very transparent and open in the beginning, is a very important move. I think it sets a new bar for how to do business.
The seismic survey, the largest of its kind carried out by Shell, was successfully completed a year ahead of schedule. In only 88 days, over 10,000 square kilometers of seismic data was collected. It's still too early to know whether Shell will be successful in its quest for oil, as the data is still being analyzed. However, Shell is proud of how it's doing business in Nova Scotia.
I think about the things that I learned that you could do back in the university, say 25 years ago. These were things that we had hoped to accomplish maybe one day, and now we're doing them, and we're doing them routinely. And so the evolution within the whole seismic imaging thing has it's just been an absolute step change.
Things in the industry are just moving so quickly, and Shell typically wants to be at the forefront of that move. If there's new technology around, we want to be demonstrated as being the people who are putting that technology to use, making those innovations, and reaping the benefits from them.
It takes incredible coordination, careful planning, but I have tremendous pride in the work and commitment we have to make sure things are done both with excellence, but also with total commitment to making sure that things are done safely, but in a way that I think will make us all proud as employees, and will make the communities we serve very proud to have Shell as their partners.
We have great hopes that this is going to be a successful survey, and that's why we've invested so much in this technology, to make sure that we're throwing everything we can to get the best possible result.